In this video, we'll start to cover the implications of the two key ideas from the last video, that F equals ma and that forces are vectors. We'll cover two key ideas and then solve a basic problem using them. The first key idea is that forces can be added, subtracted, and multiplied by scalars, just like any vectors can. So, when we see an equation like mass times acceleration, which is a scalar quantity, mass times a vector, acceleration, and say that this is equal to the force, remember that the resulting force can be a sum of forces, or a difference. A question we'll try to answer in this video is, if a block of mass m is sitting on a table at rest, with what force is the table pushing up on the block? To answer this, we'll need the second key idea from F equals ma, which is that if acceleration is 0, we know that the net forces on an object are 0. So if the block is just sitting still on the table, its acceleration is 0, and thus the net force on it is 0. Now a couple of definitions that we'll use throughout these videos to make the next part of solving this easier. So any object on Earth is being pulled towards the Earth, as it turns out, with force m times g, where m is the mass of the object, and g is a gravitational constant. We can denote this gravitational force that works on any object as F sub g, as we've done here. And the value of this gravitational constant is 9.8 meters per second per second. Finally, the normal force on any object, which is an odd name for a force, but it's the force pushing up against the object from a surface perpendicularly. So if the object is sitting on the table, the normal force is the force of the table pushing up on the object, assuming the table is flat. So, since the object is still, its acceleration is 0, we know that the net force on the object is 0. That means that the normal force plus the gravitational force is 0, and since the gravitational force is negative mg, we know that the normal force is positive mg.